Hey guys, Moncat Productions here. So I just wanted to film a little video about some AI stuff that's kind of cool. Um, but so first of all, basically, me and my friends, we've noticed that like when we're working on vibe coding, like sometimes the models are just way better, and sometimes they seem way worse. So it's like you give it a task, you tell it to code something, and the output is just not very good. And then a different day, different time, you give it the same task or a similar task, and you get really good output. And it's almost like playing the lottery, um, instead of actually like being productive. You're like gambling on whether the AI will give you good output or not. And I've also noticed this with like the chat interfaces like this, where sometimes I just feel like I'm chatting and the answers are stupid and it like feels like it's ChatGPT 3. Like if you guys remember the old days, like 2022, when ChatGPT 3 came out and it was cool, but it was not good. And then we have like Grok 3, Grok 4, and I'm just chatting with it and I'm like, this feels super bad. And then other times I ask it like a super niche question and it just like gives me a brilliant response, very good response, helps me out with whatever I'm doing. And so I was kind of wondering, maybe what's going on is that under the hood, these companies that run Grok, so XAI, OpenAI, which has ChatGPT, Claude, or Anthropic, which has Claude, uh maybe they're hosting these models and they have like gigantic GPU clusters, and obviously part of it is training, so that's where like they train the models, but then they also have inference, which is what happens when you give a model input, is they have to run inference and it takes a bunch of GPU power to do that. um so I was wondering, like, can they tune it up and down based on like peak usage times. So for example, let's say it's like, I don't know, Wednesday 3 p.m., everybody's coding, everybody's using the models. Maybe, and they only have a limited amount of GPUs, so maybe they just like somehow scale down the strength of the models, and so effectively um the model becomes stupider. And then other times, maybe like 2 a.m. when nobody's using it, they scale it up and the model becomes smarter. And so I asked Grok about this, and it basically confirmed that this is possible. Now, we don't know that they're doing this for sure, but my bet is that they are definitely doing it. And so here's what they could do. So first it mentioned model switching or routing. So that's when it like switches to a different model. But I don't think this one happens because that's kind of just like fraud, right? Like, if you're like, I'm using ChatGPT 4.0 and then it just under the hood switches it to GPT 4.0 mini. Like, I don't think they do that because that would be like, mm, that's just unfair. But apparently, like for Grok, they use mixture of experts, which is when you have one model and then you have a bunch of like other submodels and they all do some computation, and then the kind of the boss model takes all the outputs and combines them into one. Um, So they could be doing that, and so maybe they're turning that off or limiting the amount of experts, so your responses become worse. Um, Claude might switch between variants like Claude 3.5 Sonnet and lighter ones, so maybe they just have like internal models that are all called the same. So it's still Claude 3.5 Sonnet, but then sometimes it's just like Claude 3.5 Sonnet Lite, and the user thinks it's the same model, but it's actually not. Um, and then there's also context windows. So, I mean, this one, I don't know. This kind of depends, but that just means like limiting the amount of context the model remembers. Um, which I'm pretty sure that's set in standard, so maybe this one not as much. But here's where it gets interesting. So, quantization and precision reduction. Reduce the model's numerical precision from 16-bit floating point to 8-bit or 4-bit integers during peaks. This compresses the model, speeding up inference and reducing memory use, but it slightly degrades accuracy, more factual errors or less creative responses. Tools like NVIDIA's TensorRT LLM enable this on the fly. Okay, so this is very interesting. So what is this saying? This basically means that because under the hood, the model's not talking or thinking in text, it's just a bunch of numbers. And so what you can do is you can tune down the precision of the numbers so that they use less memory and it's faster to do math on them, which allows the mod, which basically saves you resources. Um, and so when they upscale, they would use the full precision, and then when they're downscaling during the peak, they may basically make the models dumber. And so it says quantized models are dumber in subtle ways, like poorer handling of edge cases, but the difference is often minor for simple queries. So, to me, this is kind of the key one. I I have a feeling this definitely happens. Because I mean, what else do they do, right? Like they have peak hours and they have, non-peak hours, and compute is like it's cheap, but it's also expensive at the scale that they're running it. So this makes a lot of sense to me. Um, and now there's some other stuff I don't exactly fully understand, but there's like chain of thought or long thinking. So this is basically how long the model can like talk to itself, which is like thinking. Um, and that's like for thinking mode models. And then sampling strategies. Um, so apparently this is where they take a few so they generate a few responses and then they kind of like pick the best out of them. Also interesting. And then during peaks they can, revert to just less sampling or less time for thinking. And then this is context window again. Um, and then like tiered access. But I'm talking specifically about like same model, same user, but just different times. Is the output the same? Is the model dumber sometimes? And I also have a feeling that this is speculative, but I have a feeling that when they release new models, they usually like run it on full steam to make it like feel really good. And then everybody starts using it. They're like, oh my God, this is the best model. This is like so much better. This is state of the art. And then maybe like a couple weeks in, they're like, okay, everybody likes the model. Now we're gonna tune down the compute a little bit. It's gonna be a little dumber, and we're gonna kind of save that compute. Um, so yeah, definitely an interesting thing. Um, I mean, I would want to know like what if which of this which of these things is going on. That would be interesting to me. Um, so yeah, let me know what you guys think in the comments. And real quick, I want to show you guys. So this is VO3. This is the Google video model. And so I've been working on trying to make a little movie out of that. Um, it's it's a cool model, don't get me wrong. And you've probably seen a lot of it online, but it is kind of limited. So, for example, every clip that it generates, it's only 8 seconds long. So that's one limitation. And then it doesn't always get like the the characters don't always talk to each other correctly. Sometimes the wrong character says something. They don't always use like good expression. But I'm trying to make something cool, so we'll see how that goes. But anyways, thanks for tuning in and hope you have a good day. And yeah, let me know what you think.